Electrostatics.
Good morning, student. Today we have to study the meaning of capacitor and their capacitance. First of you, we already studied in 11th standard, that is resistor, function of resistor. Resistor produce the resistance, and again it also allows the flow of current. Right? Again, when the current is flowing through the circuit or conductor, then at that time their heat energy is produced. But that resistor cannot be stored the heat energy. So that's why here we want to construct a such device which stored the electrical energy. Right? And the name of that device is capacitor. First of here, capacitor, which is a consist of the two conducting plates. This will be the first plate and now this will be the second plate. To the first plate we give the potential, right? Positive potential V. Here, due to that, what happened here? The number of positive charges which is deposited on the inner side of the first plate, and the negative charges which is induces on the inner face of the second conductor or second plate, and the other side of the second plate is earth. Right? Here these two conducting plates which is separating by some distance, suppose that distance is d, then such a device called as the capacitor. Right? Then this capacitor which stored the electrical energy when the current is flowing through the circuit. Here the number of charges on this plate, now this will be the positive charge and now this will be the induced charge. Right? Here the number of positive charges on a conductor is depends on the applied potential. If we increase the potential, then their number of charges which is also increases. Right? So that's why charge is directly proportional to the V. So here we want to avoid this proportional sign, we want to take the equal sign. So what we get there? Q which is equal to the, now here instead of this proportional sign we want to take equal sign. For that we want to take the one of the constant. Suppose here if you take the constant is C, and now this V is as it is. Here C is the proportionality constant and the same constant called as the capacity of a capacitor, or again in short that is also called as the capacitance, where C is the capacitance. C is the capacitance. Right? So what we get there, equation is C which is equal to the, what we get there, charge upon V. Right? So this will be the simple formula of the capacitance. But here this capacitance which is measured in farad, what we get there, we measure in farad which is equal to the, here the charge which is measured in coulomb, right, and electric potential which is measured in volt. Suppose here if we want to define the 1 farad of capacitance, then what we get there, 1 farad of capacitance is defined as, if we give the 1 coulomb of electrical charge to the conductor and due to that there 1 volt of electric potential difference is produced, then such capacitance called as the 1 farad of capacitance. See here, what we get there, 1 farad which is equal to the 1 coulomb upon 1 volt. Or sometimes again which is defined as 1 farad of capacitance is defined as, if the 1 volt of electrical potential rises when, or if 1 coulomb of charge is given to it. right? It means that if we give the 1 coulomb of charge to this one, and due to that if there 1 volt of electrical potential difference is produced or increases, then such capacitance called as the 1 farad of capacitance. And now in here, farad is the big unit. Most of the times we use there, the units are, that is the microfarad, then what we get there, nanofarad and picofarad. Suppose that if we want to find out the converting factors, here 1 micro means there 10 raised to minus 6 farad, right? Nano means there 10 raised to minus 9 farad, and pico means there 10 raised to minus 12 farad. So this is the converting factors, right? And again here, if we want to write that unit is full form, then we write in small letters. But if we want to give the symbols only, then we write there capital F, right? Capital F is also the farad, that is the unit of capacitance, right? So this is about the capacitor and capacitance, right?